So this is a question in which we have to apply the current division rule. Question is, in the following circuit, find the current through each resistor using current division rule. Also find the voltage applied across the circuit. So this is a parallel circuit. Three resistors R1, R2 and R3 are connected in parallel. And we have to calculate the current flowing through each of the branches or each of the resistors, and also the total voltage applied across the circuit. So let us mark those currents. So let current through R1 be I1, current through R2 be I2, and current through R3 be I3. So we have to calculate I1, I2 and I3, and also the total voltage V. Okay, and it is given that we have to use the current division rule. Okay, then applying current division, I1. So what is the equation for I1? According to current division rule, the current through a particular branch is equal to total current. Let us mark this total current as I. Total current into opposite resistance divided by sum of resistances. Okay. So while calculating I1, the total current is 12 ampere into opposite resistance. So I1 is the current flowing through this branch, through this 4 ohm resistor. So here the opposite resistance means there are two resistors connected in parallel. So as the opposite resistance, we have to consider the equivalent resistance of this parallel combination. So the opposite resistance will be the equivalent of 2 parallel to 8 ohm. Okay, so that is while we are doing current division among various parallel branches, one of the branches will be the branch that we are considering, and all the remaining resistors which are connected in parallel will be treated together as the opposite branch. അതായത് നമ്മൾ കറണ്ട് ഡിവിഷൻ റൂൾ ചെയ്യുമ്പോൾ രണ്ട് ബ്രാഞ്ചസേ ഉള്ളൂ എന്നുള്ള അസംഷനിലാണ് നമ്മൾ പ്രൊസീഡ് ചെയ്യുന്നത്. ഒന്നെന്ന് പറഞ്ഞാൽ ഏത് ബ്രാഞ്ചിലെ കറണ്ടാണോ നമ്മൾ കാൽക്കുലേറ്റ് ചെയ്യുന്നത് അതാണ് ഒരു ബ്രാഞ്ച്. ഇനി ബാക്കിയുള്ള ബ്രാഞ്ചസിൻ്റെ എല്ലാത്തിൻ്റെയും കൂടി ഇക്വലൻ്റ് എടുക്കുക, ഇക്വലൻ്റ് റെസിസ്റ്റൻസ് എടുക്കുക, അതാണ് അതർ ബ്രാഞ്ച് റെസിസ്റ്റൻസ്. So here we are considering the current through this 4 ohm. So other branch means these 2 ohm and 8 ohm in parallel. So this is one branch and this is the other branch. Current flowing through other branch is this current. That is current flowing to the parallel combination of these two resistors. So total current I into opposite resistance means equivalent of 8 parallel to 2. So 8 parallel to 2 ohm divided by sum of resistances. That means sum of resistances, or means the resistance of the branch that we are considering plus other branch resistance. So here it is 4 ohm plus other branch resistance is 2 parallel to 8 or 8 parallel to 2. Okay. Now what is equivalent of 8 parallel to 2? 8 parallel to 2 becomes R1 R2 divided by R1 plus R2. That is 8 into 2 divided by 8 plus 2. So this becomes 16 divided by 10 or 1.6 ohm. So now calculate the current I1. So 12 into 1.6 divided by 4 plus 1.6, and we will get the answer as 3.428 ampere. 3.428 ampere. Okay. So this is I1. Now let us calculate I2. So hope you understand the concept of current division. Now let us calculate I2. So I2 is the current flowing through this branch. Okay. So which will be equal to total current into opposite branch resistance. So if we are considering this branch for calculating the current, then opposite branch means all the remaining branches together. That is, here this 4 ohm and this 8 ohm are in parallel. So opposite branch means 8 parallel to 4. So equivalent resistance of 8 parallel to 4 divided by sum of resistances. That is, resistance of the branch that we are considering plus the resistance of the other branch. That is, resistance of the branch that we are considering is 2 plus other branch resistance is 4 parallel to 8 or 8 parallel to 4. Okay. Now equivalent of 8 parallel to 4 will be 8 into 4 divided by 8 plus 4. That is 32 divided by 12, and the answer will be 3.1667. 3.1667. Okay, and substituting this value here, we will get total current I, that is 12, into equivalent resistance of 8 parallel to 4 is 3.1667 divided by 2 plus 3.1667, and the answer will be 6.856 ampere. 6.856 ampere. So we have got the value of I1 as well as I2. So now let us calculate the value of I3. I3, similarly, I3 is equal to total current into other branch resistance. So see, so I3 is this branch. So while we are considering this branch, other branches are these two. So this is one branch and these two branches together constitute the opposite branch. So other branch resistance is 4 parallel to 2. Okay. So total current I into 4 parallel to 2 divided by sum of resistances. Sum of resistances means resistance of the branch that we are considering plus the other branch resistance. So resistance of the branch that we are considering is 8 ohm. So 8 plus other branch is 4 parallel to 2. So now let us calculate the equivalent of 4 parallel to 2, which will be 4 into 2 divided by 4 plus 2. That is 8 divided by 6, and it will be equal to 1.333 ohm. 1.333 ohm. Now substitute this value here. We will get total current 12 into 1.333 divided by 8 plus 1.333, which is equal to, the answer will be 1.7143 ampere. So this is the value of I3. So now we have calculated all the currents I1, I2 and I3. So we can check whether I1 plus I2 plus I3 equals 12 ampere. So we have the total current as 12 ampere. Now we have calculated I1, I2 and I3. So thereafter just check whether I1 plus I2 plus I3 equals 12 ampere. So now we have to calculate the voltage applied across the circuit also. This total voltage V. So according to Ohm's law, total voltage can be calculated as V is equal to IR. So total voltage will be equal to total current into total resistance of this circuit or equivalent resistance of this circuit. Okay, that is one way. Otherwise, the simplest method is we know this is a parallel circuit, so voltage appearing across each of the branches will be the same. So this voltage V will appear across R1, R2 and R3. So the same voltage V appears across R1, R2 and R3. So in order to calculate V, we need to calculate the voltage across R1. So it can simply be calculated because we know I1 and R1. According to Ohm's law, V is equal to IR. So here it is I1 into R1. So let us calculate. So total voltage is same as voltage across R1 because this is a parallel circuit. R1 is connected in parallel with the voltage source. So this voltage and voltage across R1 will be the same. So we can write applied voltage equals voltage across R1, which is equal to voltage across R1 is, according to Ohm's law, V is equal to IR, and voltage across R1 is current through R1 into resistance, that is I1 into R1. So I1 R1, which is equal to, we have calculated the value of I1 as 3.428 ohm. 3.428 ohm. 3.428 ampere into R1. Value of R1 is 4 ohm. R1 is 4 ohm. So 3.428 into 4. So this will give the value of applied voltage V in volt. Current into resistance I1 into R1. 3.428 into 4. We will get the voltage across R1 in volt, which is the same as the applied voltage.